You're welcome back to another section of my YouTube channel tutorial. So in this video, I'm going to take you through problems of limits in multivariable functions. Okay, so we are going to find the limit of certain multivariable functions. I have two problems I'm going to take you through. So please stay glued to your seat, and if this is the first time you have been on this channel, kindly subscribe to support and watch this video to the end so you understand every part of it. So how do we tackle this problem? The first one says that we should find the limit as xy approaches 0, 0 of the expression x minus 4y over 6y plus 7x. So let me take you briefly through the concept of limits. Okay, so when we say limits, we are trying to see the behavior of the function whenever we approach a certain point. But there is one condition for limits. The condition is that wherever path you take, okay, wherever path you approach that particular function from, you should always get the same limit. So assuming the limit of a function is 0, whatever path you take whatever path you take, you should arrive at 0. You should get the limit to be 0. You should always arrive at 0. So now, let me go straight to what you have here. So at this point, this is a multivariable, that is, it has two variables. So how do I find the limit? So normally, the first thing to do is to test your limit values. So straight away, put your limit values. You are going to get 0 minus 4 multiplying 0, all over 6 multiplying 0 plus 7 multiplying 0. So this will give you something undefined or indeterminate, okay, indeterminate. So meaning you can't determine it. We need some confirmatory test before we can go ahead to say the limit of this particular expression. So how do we do that? So we will assume some paths. We call it path, okay, paths. That's why I said for limit to exist, no matter the path you approach the function, you should get the same limit. So let's choose a path from, let's say, the line s is equal to 0, okay. So whenever you are choosing paths, you substitute the path into the equation so that you get the equation or the expression only one variable, then you find the limit. So here I'm going to get something like limits, wherever I see x, I'll put 0. So I get limits of what? Negative 4y over 6y as y approaches 0. That's all. So here y will cancel y. What am I getting? Negative 2 on 3, right? So when I took the path s equals 0, I got a limit of negative 2 on 3. So whenever I take any different path, I shouldn't get any other limit except negative 2 on 3. Else, the limit doesn't exist. So let me take another path. Let's say y equals 0. Wherever I see y, I'll put 0. So this is 0. This will move to 0. I'm going to have x over 7x. Limit as x approaches or 0, right? So here, what am I getting? I'm going to get this will cancel this. So let's see. So when you put y equals 0, yes, this will go. You get x over 7x, and that should cancel. Then you get what? Something like 1 on 7. You see, this and this are not the same. Therefore, you say the limit doesn't exist. The limit doesn't exist. Okay, so that is for the first part. So let's see the second part of the problem, which is x squared minus y to the power 6. X squared minus y to the power 6 over xy cubed as xy approaches 0, 0. So as usual, the first thing I said you should do is put in your limit values to see if you get a definite limit as your solution. If not, you go on with other tests. You realize that if I put 0, 0 here, it's obviously going to be what? Indeterminate, okay? So we move straight taking part. So which part should we take? Which part? So we should take part that will fit the function or for easier simplification. So we can assume one part to be, let's say, S is equal to Y. So when S is equal to Y, wherever I see Y, I'll put what? X, right? Or you can even make it wherever I see X, you put Y. So it's X is equal to Y, meaning where I see X, I'll put Y there. So my function is now going to be Y squared minus Y to the power 6 all over Y multiplying Y cubed. Limit as Y approaches 0. So for this part taken, I'm going to get something like Y squared minus Y to the power 6 all over Y to the power 4, right? I can factorize Y squared, so Y squared 1 minus Y to the power 4 over Y to the power 4. I can cancel, and I'm going to get something like 1 minus Y to the power 4 all over Y squared. So when I put 0 here, I'm going to get something like 1 over 0. That is infinity, right? So we put it down. Now let me take another part. A part say, let's say S is equal to Y cube, okay? So S is equal to Y cube. This is another part. You can choose different parts, but the assumption is wherever part you take, you should get the same limit. So wherever I see X, I'll put Y cube. Here, I'm going to get Y cube all squared minus Y to the power 6 all over X becomes Y cube multiplying Y cube. Limits as Y approaches 0. So here I'm going to get Y to the power 6 minus Y to the power 6 all over Y to the power 6. Limits as Y approaches 0. So what is this? 0 over Y to the power 6. Everything is equal to 0. Now, I took one part, I had infinity. I took another part, I had 0. What does that mean? Since I got two different limits using two different parts, the limit doesn't exist. So this is the end of this tutorial. Thank you. See you in the subsequent tutorials. Please don't forget to like, subscribe, and share.